Diagram of a convex lens. Diagram of a convex lens. We have to draw a diagram of a convex lens. In the diagram, this is a convex lens. In the diagram, this is a convex lens, and it should be a double convex lens. This convex lens is a double convex lens. The two curved surfaces of this convex lens are convex, and this vertical line xy is the aperture of this double convex lens, and this horizontal line of the convex lens should be the principal axis. This horizontal line is the principal axis of the double convex lens, and we can denote the direction of incident ray of light. Ray of light is traveling towards left, ray of light is traveling towards left, and it will be incident on this convex lens. P1 is the pole of the first surface x P1y, O is the optical center, and P2 is the pole of the second refracting surface x P2y of the convex lens. X P1y is the first refracting surface, and similarly x P2y will be the second refracting surface of. Now we can denote the center of curvature of the lens. C1 is the center of curvature of the first refracting surface x P1y of the lens. C1 is the center of curvature of the lens. Center of curvature of the first refracting surface x P1y of the lens. Similarly, we can denote center of curvature of the second refracting surface x P2y. Here C2 is the center of curvature. C2 is the center of curvature of the second refracting surface of the lens. In this case, ray of light is incident on the first refracting surface x P1y of the lens. The ray is incident on the first refracting surface, and P1 is the pole of the first refracting surface x P1y, and here xpny is the first refracting surface. C1 is the center of curvature of the first refracting surface. Similarly, xp2y is the second refracting surface. P2 is the pole. Now we can denote the second principal focus of the convex lens. Here we can denote the first principal focus, that is f1 is the first principal focus of this convex lens. Similarly, on the other side, we can denote the second principal focus. f2 is the second principal focus of the convex lens. Second principal focus, f2 is the second principal focus of the convex lens, which exists between the optical center O and the center of curvature C1 of the first refracting surface. In this case, f1 is the first principal focus. f1 is the first principal focus of the convex lens. First principal. Now the second principal focus f2 is the midpoint of optical center O and center of curvature C1. The point O is the optical center, no deviation point. O is the optical center, which is the no deviation point, and xy is the aperture. The vertical line xy is the aperture of the double convex lens. xy is the aperture of the double convex lens, and aperture is the effective diameter of the transmitting area of the double convex lens. xy is the aperture of the lens. O is the optical center and xy is the aperture of the lens. Now P1 is what are P1 and P2? P1 is the pole of the first refracting surface x P1y. P1 is the pole of first refracting surface of the lens. First refracting surface. Similarly, P2 is the pole of the second refracting surface x P2y. P2 is the pole of the second refracting surface x P2y. P1 is the pole of the first refracting surface. P2 is the pole of the second refracting surface. And here first refracting surface is xp1y and second refracting surface is xp2y. C1 is the center of curvature. C1 is the center of curvature of the first refracting surface xp1y of the convex lens. C1 is the center of curvature of the first refracting surface. Center of curvature of the first refracting surface xp1y with respect to the incident ray of light. Center of curvature of the first refracting surface xp1y of the convex lens. Similarly, C2 is the center of curvature of the second refracting surface xp2y of the convex lens. C1 is the center of curvature of the first refracting surface xp1y of the convex lens. Similarly, C2 is the center of curvature of the second refracting surface xp2y of the convex lens. Now F2 is the second principal focus of the lens. F2 is the second principal focus of the convex lens. F2 is also the midpoint of the optical center O and center of curvature C1. F2 is the second principal focus of the convex lens, which is the midpoint of the optical center O and the center of curvature C1, center of curvature C1 of the first refracting surface. F2 is the second principal focus, which is the midpoint of optical center O and the center of curvature C1 of the first refracting surface with respect to ray of light. xp1y is the first refracting surface and F2 is the midpoint of optical center O and center of curvature C1. Similarly, F1 is the first principal focus of the convex lens. F1 is the first principal focus of the convex lens. And under bracket, this first principal focus F1 of the convex lens is the midpoint of the optical center O and the center of curvature C2 of the second refracting surface. F1 is the first principal focus, which is the midpoint of the optical center O and the center of curvature C2. F1 is the midpoint of optical center O and center of curvature C2. The horizontal straight line C1, C2 connecting the two centers of curvature is the principal axis. The straight line C1, C2 is the principal axis of the lens. The distance between C1 and C2, or the straight line C1, C2 is the principal axis. Now we can denote the different distances. We can denote the focal length of the lens here. F, small f, is the focal length of the convex lens, which is the distance of second principal focus F2 from the optical center O. F is the focal length of the convex lens, and we can denote radius of curvature of the first refracting surface. Here R1 is the radius of curvature of first refracting surface, though it is measured from the pole P1, but it should be measured from the optical center. Similarly, we can denote the distance, radius of curvature of the second surface. R2 is the radius of curvature of the second surface. F is the focal length. Of the convex lens. F is the focal length. Small f is the focal length of the convex lens. F is the focal length of the convex lens, which is the distance of second principal focus. F2 from the optical center O. F is the focal length of the convex lens, which is the distance of distance between the second principal focus and optical center is the focal length of the convex lens. Similarly, R1 is the radius of curvature of the first refracting surface of the lens, we can denote the radii of curvature or radii of curvature of the two lenses. R1 is the radius of curvature. R1 is the radius of curvature of the convex lens, or radius of curvature of the first refracting surface xp1y of the convex lens, xp1y of the convex lens. And R2 is the radius of curvature. R2 is the radius of curvature of the second refracting surface xp2y of the convex lens. R1 is the radius of curvature of first refracting surface, and R2 is the radius of curvature of the second refracting surface.